All right, today we'll be talking about a new tool, and of course, most famous one in recent times, most commonly used Kubernetes. Hope you can see my screen. So, we have seen Docker Swarm, right? So, what it does, it's a cluster. Simply to keep it simple, it's a cluster where, sorry, we add multiple servers together as a cluster and then we deploy our applications, our containers, which will obviously, run these containers in any of those machines as a part of the cluster because they're all connected together. So which will deploy your containers and we can able to access even though no matter where the container is running, in which machine it's running, it will work because they're all run. It will work. Why? Because they're connected as a cluster. That's why. So it's a cluster. Okay, it's fine. All good is working fine. Okay, Docker Swarm is fine. For the cluster, but there are few limitations. What are those limitations? One thing is auto scaling. There is a concept called auto scaling, where let's say if in Docker Swarm what we did, we ran three containers, correct? So three or five, let's say. Okay, it's fine, it's running fine, no issues. Now suddenly for three are not enough because the traffic is huge. Our application got too many users now, too much traffic is there. So what we have to do? We have to increase the count, container count from 3 to maybe 10 or something as an example. Maybe let's say 10. But here what's happening is we don't know when the traffic will be coming up. Maybe at night 12 a.m. the traffic got increased. How do you know that? How can you increase, you know, the containers count at that time because you're sleeping? How can you increase that? Or maybe morning 3 o'clock or something. You won't be online, right? Or even if you're online, you have to do it manually. It means you have to increase the container count manually, which is not a good practice. So it should happen automatically when there is an too much traffic. It should increase the container count automatically, or resources automatically. Generally, if you ask me, if the traffic is less, it should reduce automatically. So this concept is called auto scaling. High availability is different. Auto scaling is different. Remember that high availability is something like maintaining the application. If you say three containers, it will maintain that three containers or three servers. But auto scaling, increasing or decreasing the count depends on your load. So this Docker Swarm, it is a good cluster. We can able to use. There is an automatic load balancing setup, right? We don't need to do anything, which is good to use. But there is no auto scaling, which is very important because see, as told you, right, for huge applications, for big applications, without auto scaling, you cannot increase the count manually there. That's why auto scaling is important, and Docker Swarm does not provide that. Got it? That is one common thing which Docker Swarm is not providing. And one more thing. there is a concept called not a rollbacks. It's a concept called rollbacks. What does it mean, rollback? Let's say we have deployed in a container. I think we have discussed this already, but yeah, let's see. You deployed. Remember, in the last class, I deployed Nginx Alpine first, and I deployed. I updated the image to Nginx latest image. I mean, update the image. Let's say now I want to go back. I want to go back to previous version, which is called rollback. But in Docker Swarm, it's not possible. The rollbacking is not possible because it does not store your state. Your state means whatever you did, it does not store that information. So you cannot roll back to previous version of your deployment. It means from Nginx latest, you cannot go to Nginx Alpine, which we updated. It's not possible. These two became disadvantages for Docker. So Docker Swarm is very good. I mean, actually, it's easy to set up, right? Easy to set up, easy to deploy our containers. But these two became disadvantages which were required for every application. So what to do now? So there is some tool came after that. This is called Kubernetes. Kubernetes, where whatever the disadvantages it has, it's the same thing. I mean, if you ask me what is Kubernetes, it's the same thing as Docker Swarm. It is a cluster. It is a cluster only to manage your containers, to manage, your application and all these things, load balancing, with extra things like what Docker is missing, like, as I told you, mm, auto scaling and rollbacks. With these features, Kubernetes became, most popular compared to Docker Swarm. So now, as I told you, right, which is very important. I mean, Docker Swarm not providing these two features, which are very important for our application. But sorry, Kubernetes is providing all those things. So that's why Kubernetes became famous in the market. That's why not not many uses, Docker Swarm. So to keep it simple, Docker Swarm is a cluster to manage Docker containers. Similar way here also, Kubernetes is a cluster to manage your Docker containers or applications, whatever it is. Both are same, similar concepts. Got it what I'm saying? But the way Kubernetes works is a little different compared to Docker. I mean, of course, it's the same thing we deploy containers only and all those things. Of course, as I told you, right, the architecture is different. In Docker Swarm, the architecture is different. In Kubernetes, it's different. Always. Sorry. So there are a few differences. I mean, there are like in how we set it up, how we access it, how everything works inside. There are a few fundamental differences between those two. We'll discuss all those things one by one. So usually they'll ask, in general common question they'll ask, what is the difference between Docker and Kubernetes? General question they'll ask. Simple, these two are the major differences. And of course, Kubernetes has something called UI also, where from browser, just like Jenkins and all, UI is there, right? Similarly, like that, Kubernetes have UI. We can use that to deploy, sorry, to deploy all our resources in cluster, Kubernetes cluster. Yeah. So generally there, I'll show the differences. See, Kubernetes versus Docker. There's a common question they'll ask. Very small differences. Maybe this one. Yeah, this one. Let's open. No, this is too much. Docker Swarm. See, let's open what are the differences between. Where the hell is, yeah, this is the one. These are the differences between Kubernetes and Docker. See what is not there first. Observe UI. UI is okay. Ignore this is an optional feature. Check the remaining thing. Auto scaling is not there. See, load balancing is there, obviously, but auto scaling is not there. Observe here. This is a very common, uh, requirement for every application. Without that, we cannot deploy. As I told you, right? What are those things? Auto scaling, load balancing, high availability concept. I mean, auto scaling we can consider as high availability concept only, but a little difference. Without these concepts, no one deploys the application. No. Why? Because that's required for those are minimum requirements for the application to use. And of course, load balancing, of course, in Docker Swarm, load balancing is automatic. We haven't done anything, right? We haven't created at all. But in Kubernetes, we need to create the load balancer manually. That's the difference. And of course, you may see Kubernetes Docker Swarm setup is easy, but Kubernetes setup is too complicated. Too complicated means we can do that, but we have to follow specific steps. Then only it will work. Otherwise it won't work. But and it seems there is something called cloud integration, which will come later. Don't worry. Rollbacks they haven't given here, but yeah, rollbacks are also there. Got it. So these are few differences which Kubernetes have few advantages. Of course, there are few disadvantages as well with Kubernetes because, as I told you, it's complex to install. Docker is easy, right? Docker Swarm init, that's it. But Kubernetes, I have to install blah 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 all these things, blah blah. So many are there. We'll see that tomorrow, maybe not now. So sorry. These are few differences between Docker and Kubernetes. As I told you, there are same thing. Both are clusters. Both are orchestration tools. Orchestration. You might have heard this word. Orchestration. What does it mean? See, to keep it simple, orchestration means management. Managing something. Or yeah, this is another definition. Act of coordinating a collection of different elements to achieve unified desired outcome. This is a professional way of saying it, but yeah, orchestration to keep it simple, managing something. Some people say like Kubernetes is a container orchestration tool or Docker Swarm is a container orchestration tool. What does it mean when they say it orchestration is management, managing the containers, managing the tool, or managing the the features or components inside the tool. These two are these two works for orchestration only. But container orchestration, container level orchestration, not server level. We don't manage servers here, right? We manage the containers. So Docker Swarm and Kubernetes, both are same. I mean, both are same means both are there for the same purpose, container orchestration. But the difference is how they manage, how they handle it, and what they provide to your containers. Those are the difference, and how we use it, obviously. Yeah, got it. There's minimal thing, which I would say. Kubernetes have different architecture, different way of working, deploying things. Docker Swarm have different architecture. Again, a different way of deploying things. Both are different, but the goal is same. That's the thing. The goal is same. Right? What is the goal? To deploy your containers, to manage them, provide auto scaling, load balancing for all of them. All right. So let's go to our Kubernetes tool now. Enough with the Docker, what we have. Kubernetes, how it works, what are some components inside it. If you ask what are the components inside Docker Swarm, we have it's a cluster, right? Obviously, we have master and slave. I mean, worker. Sorry, you can call it slave also. It's fine. So master and slave, as well as like a manager, leader to no to manage the cluster and everything, and overlay network which automatically gets created. So all these things will be there. Similar way in Kubernetes also there is an architecture. So everything has a meaning, obviously. Let's see. No need to write like Kubernetes every time. K8s also is fine. K8s means Kubernetes only. What does it mean K8s? Why they call it K8s? It's simple. Observe, where is the spelling? Yeah, here is the spelling, right? Kubernetes spelling. Between K and S, between K, last K, first K and small, no, last S, there will be 8 letters. Count, you can count. Uber, 1, 2, 3, 4, NETE, 5, 6, 7, 8. That's why they call it K8s. Kubernetes or K8s. It's all are same. That's fine. So architecture means it came. Mm, no, this one. This. Mhm. Yeah, this one. Let's open this. It's look colorful. So, sorry. This is architecture of Kubernetes, how it's look like. I mean, how it looks like, what are the components inside that. Not worry, we'll go all through all those, but general, if let's start with Kubernetes. Common idea, like common thing is cluster, right? It's a cluster. It means there will be multiple servers, correct? Just like how we see in Docker Swarm. One will be master, another will be node. Same concept. That does not change. What's changed, how they interact, how they communicate, that will change. In Docker Swarm, how they communicate usually master and master or leader and the workers, how they communicate each other through overlay network, right? It's very simple over there. Through overlay network, they'll communicate. But here, it's different. Of course, the communication is the common point, but how they do it, that's the difference. Got it? So, control plane you're seeing, right? Control panel or control plane, both are fine. This control plane is master. Work node 2 means these are workers, I mean the nodes, the slaves, servers. This is a master, what we are running here. These components which will run in master. Each component have its own use case. We'll discuss all these things. So what happens now is if you want to, you'll install the Kubernetes, okay, which is fine. And now we have to choose the master, right? In Docker Swarm, what we did, we choose one master and we did init, Docker Swarm init. Similarly, in Kubernetes also we do the init. When we do the init, all these components will run in master, will will automatically gets created. We don't need to create any of these. So if these are running in that node, that became master. Because these are all master components only. Whatever the four you are saying, these are all master components. Together we call it control panel. Why we call it control panel is, if you say init, let's take remote TV remote, let's say we can call it control panel because we control the TV with that, what are the channels and everything, volume or everything. Similar way in the cluster also, in the Kubernetes cluster, these components control everything. That's why we call it control. Together we call it control panel. All combining all these components, we call it control panel. Got it? So let's start with the very first component we have, API server or API server. What is API server? API server is the one, or you can say only one component which we access usually. You can say like API server is the one component which is responsible for all these things. All these things means everything, whatever you're seeing in the cluster, starting from deployment, starting from creation, delete, update, container update, whatever it is in the Kubernetes, whatever the action, API server is responsible for that. API server is responsible for that because this is what it everything. This is the component which does everything, which handles everything. So within the four components, these are all the master components. Together, as I told you, we call it control plane. Out of these four, API server is the one which will handle everything. API server is the one which will manage, control these also, these remaining three. And we also communicate with API server only, not with any of these other components. We directly communicate with API server. To keep it simple, you know how it works. Let's take example again in Docker Swarm. Why I'm taking every time Docker, why I'm talking about Docker Swarm is, see, both are similar concepts. You already know Docker Swarm. So if I try to compare and explain, so it will be easier for you to understand. That's why. So in Docker, I want to create a container. What you do, Docker service command you will create. What happens when you execute that command? Docker client is there, right? I mean, it will take the input from you, give to Docker daemon, which is Docker engine, which is running, and it will take it. It will give the response back to output to you, right? In the command line. Similar way here also, whatever the Kubernetes commands we run, that will be taken by API server. The commands will read by API server and give the response back to you. Let's say I told, hey, Kubernetes, create this container. Okay, it will take it. It will do all the work. It will create it and tell you that, hey, it's created. Same thing. Not only just create everything, whatever you do, Kubernetes, like a Docker PS, Docker LS, or images. These are all commands, right? To execute every command, it goes to Docker engine only. Similar way here, any Kubernetes command goes to API server only. So that's why, this is the most important thing, API server. And this is the only component we by default have access to talk to. Of course, we have four components right in master. We, of course, there are four, but we cannot directly talk to these other remaining three components. We talk to API server, only this one. This API server will talk to remaining for us on behalf of us. It will talk to other components. So that's all. So this is called API server. Next thing we have etcd. Etcd is there is no full form for etcd, just etcd. It's a key value data store actually. Key value data store. What does it mean, key value data store? It will store the information in keys and values. So if you open, this one, how the data will be look like is A is equal to 10, B is equal to C is equal to 30, something like that. This is a key value data store. Just store the information in keys and values. Why they'll store like that? Why it will store, or why it is required for that? I mean, why it is required in Kubernetes? As I told you, it's a cluster. There are two worker nodes here. I mean, there are two workers or nodes or slaves. How these worker information will come to master? How master knows about those things? Of course, we connect the nodes and everything, but how to keep updated information? How does master know the latest information? Through etcd only. Etcd is the one which stores all the cluster information, cluster configuration, everything, and it reports to API server. It report to API server. Hey, I have this information and everything. Let's say we have two nodes, Linux node. One is Red Hat, one is CentOS, another is blah blah something else. All the information etcd have, and etcd always update to API server. Hey, we have two nodes. One is this, one is this. So yeah, I'm just giving you information like that. Got it? So that's what etcd does. Without etcd, it does not know. We do not know anything about the cluster. I mean, we don't know. We cannot get the cluster information. So because this etcd stores everything. Got it? And next we have controller manager. Again, controller manager is one of the component. What happens? What it does? Control manager is, this is the one. This is the one which will maintain the state of your application. What does it mean, state of my application? What does it mean is, you know, let's say you deployed 5 containers. Similar way in Docker, Swarm, what we did, we deploy 5 containers, correct? Or three, like as in anything, sorry. So it will maintain the state, right? Always. It will always maintain that, right? How there is, as I told you, high availability concept, internally Docker Swarm maintains it. Similar way, we have like, concept called controller manager where it does the same thing. Where it does the same thing. What it does exactly? So if you told in Kubernetes, hey Kubernetes, just create 3 containers and maintain it. The creation will be done by API server, obviously. etcd stores that information now. Okay, 3 containers created. Okay, let's store the information. To store the information. And controller manager is the one which maintains the state. Controller manager is the one which maintains the state. Correct? Controller manager is the one component which will maintain the number of whatever the containers we told to create. We call it like there is no other number, other name kind of thing, but we call it a state, current state, or actual state, what we wanted like that. We wanted 3 containers. Let's say we wanted 3 containers. That is my desired state, right? Which is I wanted. So currently it's running only two. It means it's actual state or current state, you can say. So I desired state is 3, current state is 2. So what happens now? They are not matching, right? Obviously. So what this will do, this controller manager will do, it will it will talk to etcd, get the information first. Okay, they wanted 3, but there is only 2 now. We should create one more. It will create that. That's what it is. Got it? That's what it does. So maintains the state for your application, whatever whatever you have decided. Clear? That's what it is. Right. So controller manager is for that, to maintain your desired state. Of course, Docker Swarm by default it does it. It's here there is a component, that's it. And that's about controller manager. Next we have something called, what is it? Scheduler. Scheduler is the one which decides where your application, I mean container, should be deployed. Scheduler is the one, it will decide where it should be deployed. What does it mean where it should deploy? We have 2 nodes. Out of 2 nodes, where the pod should go? Sorry, not don't say it pod now. Or where the container should be deployed out of 2, that it will be decided by this guy, scheduler. Got it? What does it mean? What is there to decide? You may ask, like, what is there to decide? I mean, simply it will run in both machines, right? I mean, 2 machines, right? It can run in 2, it can run in 1 also. Both are there. It depends on, again, it's all depends on our cluster information. It all depends on our cluster information. Got it? How we deploy it, where maybe let's say I have an requirement that, let's say I have a requirement that my container deploy only on second server, second node, not on first. Maybe I don't want to run on this, I want to run only on this. How to do it in Docker Swarm? We cannot do that. We cannot, we cannot do that in Docker Swarm. But in Kubernetes, we can do that. Got it? In Docker Swarm, it's not possible, but in Kubernetes, it is possible. It's one more feature you can say. I have Nginx container, simple. Let's say I have Nginx container I want to create. I want to run the container only on this server, not on this server. So that we can tell to scheduler, a scheduler run on this thing or run on this server, blah blah, all these things. Then scheduler will run in that machine only automatically. Of course, there are a few more things. Like let's say we can tell scheduler that, hey scheduler, run my container if the server has memory of 10 GB, as an example, I'm just saying, it will run like that. Or run my container if the server name is test or something else. I'm just saying as an example. So all these, we can tell to scheduler, and scheduler will do all. It can take care of these things. Not only these things, there are so many things we can able to, like, pass the information based on the inputs what we give. Scheduler will, deploy the container accordingly based on our inputs. Those inputs, when the time comes, we'll see. But for now, few things, just to remember, that's it. So these four are server components. These are server components. So what happens is like, as I told you, we'll talk to only API server, and API server will do other things, remaining things, and all these things. Got it? As I told you. So here I told, hey, I want to create three containers, two API server. API server will, what happens now? It will tell to controller manager. It will tell to scheduler, sorry. Hey, deploy it. So scheduler will check the configuration, whatever we gave, whatever the inputs we gave, and it will deploy on some server. And now what happens now? Controller manager start watching it. Controller manager start watching it. Why? Because it needs to maintain the desired state, right? I told three containers, so three has to be maintained. That's what controller manager does. It will check, it will keep on checking. If that number is not matching, it will make it that number. And finally, etcd. What this will do now? This will, no, sorry, this will maintain the state. This will maintain store all the information about what happened so far. Two containers three created. One is down for some reason. Another replaced it. All these things, it will store the information. Got it? That's what all these components does. Got it? That's what all happens in master. These are all the master components which we have. Got it? So next, okay, this is so far we just covered master only. Next, let's say we have there are a few components in node also. Node means in workers. So what happens when you add, a server to Kubernetes cluster? It automatically runs some components. Only in nodes. Those are these three: Observer, Docker, Kubelet, and something called kubeproxy. These are all the things. Of course, Docker we know. Docker is mandatory. Obviously, it won't install Docker. We have to install Docker in that machine. It uses that. So why Docker is required here? We have Kubernetes, right? Why Docker is required? See, Kubernetes just manages your containers. It does not create images or anything. It does not create images. It just manages them. I mean, it creating, deleting, updating, deploying all these things. But it cannot create image. How we create image? Using Docker build only. Docker file and all these things. So that's why a container tool is required. So now we call it container runtime, because see, we are what we're doing, we're telling Kubernetes to create containers. No, internally what it does, it will use this Docker only to create containers. So we call it container runtime. Container runtime is required. It's a component. So now in latest versions of Kubernetes, Docker won't be supported as container runtime. I mean, Kubernetes does not support Docker as container runtime. It does not use it. There are some other tools, container D, CRIO. There are some other container runtimes, container tools. Just like how we have Docker, right? There is another tool called container D or Podman. So Kubernetes we'll use them as container runtimes to manage, create containers and manage them. But of course, don't worry. Whatever the images we built with Docker can still be used to deploy in Kubernetes. So there is nothing wrong. There is no, issue because everyone uses Docker to build the images and everyone uses Kubernetes to deploy them. That's it. That's what they do. And as I told you, Kubernetes does not use Docker to create containers only. Again, it does not use Docker to create containers. There is some more something else called container D. It's simple, similar to Docker. Let's try container D. It will use this. Of course, we have to install this also. Just one command, no, don't worry. Just apt install, blah blah blah. So Kubernetes uses that as a runtime, container runtime, which is mandatory observe. It's needed. And what is this next component called kubelet? Kubelet is an agent, you can say. It's an agent which will be running on all the things, all the machines, I mean, all the nodes and all. So this kubelet is the one which will connect worker to server. I mean, to the cluster, I mean, the node to cluster, so that it will become Kubernetes worker. This always should be running. We install this as a service, like apt service. I mean, our systemctl service is right, just like in Linux. We install this as a service, and this should be running always. If this is not running, the node will be disconnected from the cluster. So we have to make sure this is running always. We have to install this agent and we have to run it. Got it? Next, something called kubeproxy. Kubeproxy. This is a networking component actually in Kubernetes. Networking component in Kubernetes means, sorry, this will uh, what is it? Create the IP. Oh, sorry, we create the pods, right? Oh, sorry, containers, right? We'll create the containers. So Kubernetes, Kubernetes component is the one which will assign the IP addresses to the containers. The networking, right? So this is the one which assigns the IP address and all those things. Communication happens through this. What is this? Through this only. You may I think in Docker what we have Docker network, correct? We have Docker network to do this. We just create a network and that's it. We'll use it. But in Kubernetes we have kubeproxy. It's a component which does the networking things, assigning IP address. Let's say if the request came, so to access the container, this is the one which will forward the traffic to the container with the container in the Kubernetes because it will manages that. It manages that. Sorry, all those components. I mean, all those networking components. Got it? That's about kube proxy. So this you may think, okay, we have to install all these components one by one. No, we don't do like that. As I told you, we install the kubelet agent. This agent obviously we need to install. Of course, this Docker we have to install manually. That's it. Remaining this server master components control plane. This when you initialize a cluster, this automatically gets created. Just like how we did Docker Swarm, we did Docker Swarm in it. It will create a Docker network and everything, right? Similar way, this will create all these components when you initialize the cluster in Kubernetes. And kubeproxy, when it will be added is when you add this server to the cluster, then kubeproxy automatically gets created. So you don't need to install any of these things. Got it? This is the architecture of Kubernetes, how everything works. Why I explained this much, this much time I took to explain all these things, because without knowing the architecture, we cannot understand Kubernetes, how it working. Of course, we can deploy the containers and everything, but how internally everything is connected, or let's say if there is some issue, where to find the issue. All these things linked to this architecture. That's why Kubernetes, see, No other tool I have explained architecture, right? Not that much because it's not needed because there is nothing much. Why I explained Kubernetes specifically is it's how important it is to know the architecture before working with Kubernetes. Got it? That's why I'm explaining all these things. Got it? So this is about Kubernetes architecture. Don't worry, there is a video. You know the YouTube channel, right? There is a video. Open that. Go through that again. Or I don't know. There is one more guy for Kubernetes. Let's see. I think Srikanth Challa. Oh no. Let me see my subscription. You should be there. Srikanth. There is one channel, Srikanth Challa. You can, of course, you can check our channel, but if you want clear more explanation, he'll say very slowly, I don't know, I forgot his name. What the hell is his name? Srinath Challa, maybe. Let me tell. Sorry, NID, Srinath Challa. Yeah, see this guy. See Kubernetes tutorial, 36 videos are there. He- Actually, he have a Udemy course. He'll ex
as a
he'll show
DevOps
you
engineer.
the real time, the whatever the implementation over there, but he'll explain clearly to you. If you do not understand this, go through this his channel. I have subscribed. Okay, I removed it. Okay, so it's very good actually. This is for Kubernetes, only for Kubernetes. See, architecture, Kubernetes. What is Kubernetes? What is architecture? Installing, blah blah blah. These are all we'll say. Don't worry. These are all the things he'll explain. So go through this. What is Kubernetes and what is Kubernetes architecture? One video once. He'll explain. Got it? So this is about Kubernetes architecture. Tomorrow we'll see the installation, how to install, blah blah blah, remaining things, how to, and installation also will take easily 30 minutes because it'll can be finished in 5 minutes, but there are few steps we need to follow. If we miss any of that, again we have to reset the whole thing. Again we have to start from beginning again. That's why I'm saying that. But yeah, it's okay. It's fine. So we'll do the installation tomorrow. For now, yeah, introduction is fine and architecture and all. Let's meet tomorrow same time and let's see. Let's discuss this. Let's continue with installation. Bye. Bye all. Have a nice day.